All right, 7.2, lesson 7.2, that's where we are today, 7.2. We're trying to get some information in for you. We're going to learn how to graph complex numbers. And learn how to graph complex numbers. Before we do that, let's review last lesson's information. We talked about imaginary numbers, talked about complex numbers. We talked about quadratic equations, so you can solve it. You also talked about being able to solve whether for I. Now, this lesson is going to talk about being able to graph them. Well, we learned something in the last section and in the last chapter, how to graph using numbers. And so the information you learned were a few key identities that you'll need to remember this lesson. In order to graph the theta, what was the theta? Theta equaled what? Tangent -1 b over a. That's correct. All right, so that was one thing you learned. What else did you learn? You learned that r squared equals a squared plus b squared. Okay. We also learned that when we put it into polar form, we also learned something specific for that, which was what? R equals what? Cosine theta, right? All right. Okay. So these are going to be important. They're going to help you as we continue to move forward. Now, in this lesson, we are going to talk about a complex number. What was a complex number? A complex number is a plus bi, right? So a plus bi. That was the original generic lettering that we learned, right? Now, think about this for a second. What's another way, and one of the things you'll learn in this Pythagorean theorem is this, is that a plus bi is going to could be rewritten and be known as this. R equals the absolute value of a plus bi. Now, if I plug that in to what we already know, how do we know that? How do we know this? Because we just showed you r squared equals a plus b squared. Another way to rewrite that is r equals a squared square root of a squared plus b squared, right? Which essentially is doing what we would say, we would be doing the absolute value if they weren't squared. So that's kind of what we're looking at. So another way to write this right here is absolute value of a plus bi is really the square root of a squared plus b squared. So all this information is very important in order for you to solve these problems. So let's think about that for a second. If this is your a and this is your b, and in this situation we have a and b, what did the a and the b represent when you did the drawings and you did the graphing in the last chapter? The a represented the x value, the y represented the b represented the y value. Essentially, this is your x, this is your y. So, if we were to look at this information, 4 plus 6i, where would you graph the 4? At positive 4, right? If I'm graphing this, I go 1, 2, 3, 4, and I would graph this at a positive 6. 1, 2, 3, 4, 5, 6. So 4 and 6. So that would be my point if this was my complex number. Does everybody understand? So let me ask you this question. So if that's my point, how would I find this distance, which is our r? How would I solve that? Using what? The Pythagorean theorem, right? So, does everybody follow what we're doing? So the first question is this. It says this. Find the modulus of 3 plus 3i. So 3 plus 3i. How would I find the modulus? The modulus is our r, right? So first off, if I were to graph this, I'd go 1, 2, 3, 2, 3. So there's my graph. All right, it's over 3, up 3. So I need to solve for this information, which is using the Pythagorean theorem, or using r equals a squared plus b squared. So, r equals 3 squared plus 3 squared, which is essentially 9 plus 9, r squared equals square root of 18. Reduce to 3 times the square root of 3. All right? So, 3 times the square root of 2. 3 times the square root of 2. So there's your modulus. How do you find that? You simply solving for r using your a plus bi formula. All right? Any questions on that information? So class, let me ask you this question. If I have that graph right there, what would be if that's my r, what would be my theta? What would be this degree? Based on this information that you have, what would be your degree? And how can you solve that? Okay? Anybody have any questions? What would you use? Of course you'll use your unit circle. Your unit circle will be what you use, and that answer is going to be pi over 4. Pi over 4. So if you look at unit circle and you look at your information, you will find that your answer is pi over 4. Now, if I'm looking for a full rotation and back to that, you're going to have 9 pi over 4. Because why? It's going to be 2 pi plus pi over 4. Well, the only way to combine those is to put a common denominator, which would make this times 4 times 4. And that's going to give me 8 pi plus 1 pi, which would give me 9 pi all over 4. And that's how I get it if it's multiple rotations, etc. All right? So let's try another one. So we can see if we are understanding this information. So, the next one they want to give us is a negative 2 plus 3i. Negative 2 plus 3i. So if I were to graph this, where would I graph it? Draw a little line. Which way is this one going to go? To the left 2. And up how many? 3. So there's my vector. I was graphing that, right? Now, if I were to ask you to solve for the magnitude and direction, you could solve for that. The magnitude would be the r. The direction is going to be the theta, okay? Your theta. So your magnitude, how far it goes is your r, and that direction is going to be based on your theta, okay? Because you need that information. So, any questions on that? So based on that information, how would I solve that? How would I solve? So first off, what would be the r? So I can solve the r. How can I solve the r, guys? Here it is, right? So it's going to be negative 2 squared plus 3 squared, all in the square root. So 4 plus 9 square root of 13, right? So we can't reduce that anyway, but right here is our square root of 13. Now, what would this theta be, and how would I solve that? Anybody have an idea? How would you get about solving how far that is? Well, we know it's going to be over 90, right? Has everybody got that part? Everybody knows it's going to be over 90. What else do you know? How else can you solve it? All right. Use your theta. How would you solve what that theta would be? A little more difficult in this case because of where it is, and it doesn't seem like it has like the first one we did had a exact number that it was hitting. So you look at your pi over chart, and you find out what that distance is based on this. Obviously, we know it's going to be greater than pi over 2, and then we got to figure out what this distance is on 2 out of 3. 2 out of 3. I don't have my unit circle, so I can't do that for you. I'm sorry, I forgot that when I came in today. All right, so that's how you would solve that. So let's do another one for practice, and then we'll be done for this lesson. And this time, they're going to give you the r, and you're going to solve the other information. So they give you a drawing, and the drawing looks like this, and it has a theta going this way, and it has it 16, and it's saying this, theta equals 5 pi over 6, okay? So they gave you that information. So what you're doing is now, is you're solving for that point. So you need a b and an a, so you can have your complex number. So how do we get our complex number from this? So first off, we have to find the r. How do we find the, we already have the r, so our r is 16, our theta is 5 pi over 6, right? So that's information that we need, right? Next information is we need to know what? So what does r equal? 16 equals a squared plus b squared. Everybody okay with solving that to that point? Everybody good with that? Any questions? So far we're good. Now, but we need to get rid of a, or we got to get rid of a b so that we can actually solve this, correct? Remember over here, remember I started with tangent theta equals what? B over a, right? Agree with me? So, what is tangent? What is theta? Right? Okay. So, tangent 5 pi over 3, 5 pi over 6 equals b over a. Now, let's think about this for a second. On your little graph, what was tangent 5 pi over 6? That is equivalent to 1 over the square root of 3. All right? Negative 1, the square root of 3, equals b over a. So now what do? We're almost done. We have to get this so that it says a equals or b equals. It doesn't matter which one. Well, in order to do this, you just do cross multiplication. A equals b, negative b times the square root of 3. Okay? So we multiply them and we're left with a equals negative b times the square root of 3. Any questions on that information? How did I do that? How did I get there? All right? Any questions on putting this in? And why did I do that? All I did is cross multiply because I'm looking for a or b, and a times 1 is going to give me a equals. Now, once I have my a, I can plug in. So we're left with 16 equals, so what's a essentially? A becomes negative b square root of 3 squared plus b squared. Now what? Square your square root, that becomes 3. Square the b, that becomes b squared. And you get rid of your negative sign because the negative sign goes away when you square it, right? So you're left with this information, right? 16 equals b squared 3 b squared. So you're left with 16 equals square root of 4b squared. Now remember, we need to get this square root away from here. So in doing so, we square both sides. In doing so, you're left with what? 256 4b squared. All right, so you can do it that way, or you can do it this way. Leave the square root and do the square root of this. Well, what's the square root of this? 2b equals 16. Your choice. Divide by 2, divide by 2. b equals 8. Okay? So once you have your b equals 8, you plug in the b equals 8 to this one, and you're left with a equals negative 8 square root of 3. So, class, if I have my a, I have my b, can you please now write your complex number? Well, the complex number is going to be a plus, or sorry, not a, 8 times the square, negative 8 times the square root of 3 plus 8i. Because here's my a, here's my b. So when they give you the magnitude and the radius, your r, or your multiple, you will rearrange it to get your complex number. All right? Any questions on that? That's 7.2. Hopefully that'll help you be able to solve these problems.